everyone, this is your air pollution part 4 notes. Make sure that you've watched part 1 through 3 prior to watching these notes, as some of the information contained in parts 1 through 3 will apply to the information here, and I do not want you confused. The part 4 notes are going to focus mainly on methods of reducing air pollution, so we'll discuss a couple of different types of reducing pollution in general and also reducing industrial pollution. We're also going to go through some of the major causes of indoor air pollution and their effects on human health. So let's go ahead and start with reducing air pollutants in general. What processes or steps we can take to help reduce air pollutants. So if we take a look at our list here, there's a variety of actions we can take. Sometimes they are going to be at the federal and legal level. For example, regulatory practices such as federal law. Remember, we've previously discussed the Clean Air Act and how it was used to help limit the amount of pollutants that are allowed to be released into the atmosphere. We could also use conservation practices. What this basically is just using less of a fuel source. If you use less of a fuel source, less combustion of that fuel source means less pollutants in the atmosphere. We could also attempt to use alternative fuels that contain less pollutants, or we could try to find something entirely clean that maybe contains no pollutants whatsoever. We've discussed a few of those in the past when we were discussing different sources of energy. For example, things like wind energy, when you're actually creating energy, don't have any actual pollutant chemicals released into the atmosphere, or hydrogen fuel cells, which use hydrogen, and the only byproduct from the production of energy with those is water. Technology could also be used to help reduce pollutants, and this is most commonly what we do now, other than regulatory practices such as laws. So the next thing we'll be talking about is a few different types of technology that can help us with that reduction. One of the first moves that was made to help reduce air pollution was changing the formulation of gasoline once we realized that lead was a serious air pollutant that needed to be reduced. Lead is toxic to organisms in high quantities, so we wanted to make sure that we were not releasing an excessive amount of that, so lead was just removed from the gasoline formulation. Other options for helping reduce air pollution included things like vapor control nozzles at gas pumps, having catalytic converters put on cars, and catalytic converters in the past have been a common question on the AP exam, basically asking what are they, so make sure you remember this one. So catalytic converters on cars, their job is to take more dangerous pollutant emissions such as nitrogen oxides and carbon monoxides and convert them into a less harmful chemical. Now, it doesn't mean harmless, but they are a little less harmful as far as pollution is concerned. So they might be converted into carbon dioxide. The problem there is it is still a greenhouse gas and contributes to warming. We could convert it into water. Or nitrogen gas and oxygen. We could also use pollution control devices on industrial exhaust equipment. So if you think of coal burning power plants and other industrial practices, they're going to be releasing quite a bit of pollution from their equipment. So we're going to talk about that next. So industrial pollution control devices, their big job is going to be to kind of scrub pollution from whatever exhaust comes out of them. So whether it's gas or just air that is being released that's containing those pollutants or particles, these systems will work to remove them from that before that gas or air is released into the atmosphere. So there's a couple of different types of devices. We're specifically going to talk about electrostatic precipitators, baghouse filters, and scrubbers. All right, go ahead and take a look at the picture on the right of this slide. That is showing kind of a general setup for a baghouse filter. What these have within them is filter bags or pleated filters that are arranged in rows. So you can see the vertical blue bars inside of the baghouse filter to the right. Those bags or filters are going to receive dirty air, and as it flows through those bags, the bags will help collect any of the particulate matter or pollutants that we do not want released into the air once that air is released from the industrial facility itself. So the filters help take that out, and then clean air is able to be released from that baghouse filter's housing. Another type of industrial filter is the electrostatic precipitator. You can see the picture on the right is a little bit complicated, so I'm going to walk you through what's happening in that. What we will have happen in this case is polluted gases or air will be pushed through the electrostatic precipitator. And the smoke or gases or whatnot that's going through there usually have particles of soot and other pollutants that we want to remove before it's released just back into the air. So the precipitator will help charge the particles that we want to remove, and they will be given a negative charge within the precipitator. Then those charged particles will be attracted to another area of the precipitator that will have a positive charge. So in the picture at the right, notice we see the grease-laden airflow on the left with the little green circle dots. That's going through the precipitator. It's being charged negatively, and then you can see the red positive charged panels. Those are going to help collect all of those particles basically by attracting them with that positive charge, since the particles have been given a negative charge. And you can see on the right that the clean air is then exiting that system, and it's effectively cleaned. The last type of industrial filter we're going to talk about is a scrubber. And what scrubbers do is they use a liquid to help remove pollution particles from the air. So whatever dirty gas is needing to be cleaned will flow into the scrubber itself, and then a liquid will be passed over that gas. And basically the liquid is just going to grab onto the particles that we want to remove and then collect them. So then once it's cleaned up through being removed out of the gas by that liquid, the clean gas can then exit the scrubber itself. Okay, next we're going to move on to indoor air pollution. Just some general trends in indoor air pollution. In developing countries, the greatest risk of indoor air pollution causing health effects is usually going to be to lower income populations. And this is because in developing countries, a lot of these lower income populations are going to be burning things like wood within the home, oftentimes without very good ventilation. And so a lot of particulate matter can end up entering the home and then eventually the lungs of who's ever living there. They may be burning charcoal, which is also a wood byproduct. They could be burning things like dung. Crop residues such as pesticides could also be making their way into the home or into the environments that these individuals live in. And then also the burning of coal for heating homes, which is highly pollutant. And then in developed countries, so our countries that have a little bit better economies, have a little bit more access to technology, our biggest danger here really comes from indoor air pollution. And it's going to be a much greater concern than the outdoor air pollution for individuals because we do spend so much time indoors. So a lot of this indoor air pollution really comes from chemicals from building materials. One of the other major indoor air pollutants that is of concern is radon gas. And radon is something that is naturally occurring. It comes from underground deposits of uranium, which is radioactive. The problem is that uranium decays because it's not very stable into radon-222. And that particular gas is able to seep into homes, usually through cracks in the foundation, and can get into groundwater used for drinking water as well. The major concern with radon is the potential risk of lung cancers due to the radiation exposure. And the radiation exposure is actually the second leading cause of lung cancer in the United States. So the biggest thing here is having good ventilation in homes. Basement homes need to make sure that they have plenty of good ventilation, and that helps prevent the radon radiation from moving into the home itself. A few other key indoor air pollutants that are problematic for human health include things like asbestos. It's an insulation material and can actually cause respiratory diseases because of the tiny fibers contained in it. Those can get into the lungs and then cause damage. Carbon monoxide is another big indoor air pollutant. This can come out of the tailpipes of cars. It can come from heaters within homes, and the biggest problem here is that it binds to hemoglobin in the blood of organisms instead of oxygen. So if you are not having oxygen brought throughout your body to all of your cells by the hemoglobin in your blood, it kind of suffocates you internally. VOCs, so your volatile organic compounds, which are found in furnitures, glues, paints, carpeting, and lead paint. These can be carcinogenic. They can be a lung irritant. So any strong smells. So for example, if you've ever used not really a school glue, but like an industrial kind of strength glue, and that strong smell that comes off of it, those are all VOC chemicals. And then also tobacco smoke. Some of these indoor pollutants can actually be so bad in concentration that after new buildings are built, we actually have a name for the illnesses that can be caused. It's known as sick building syndrome. So when a new building or a newly renovated building gives off high levels of those volatile organic compounds, or sometimes it's referred to as off-gassing, this can be from the glues, the paints, furniture, and other products that are put into that building. These can all cause irritation of the lungs. They can cause headaches. They can can cause eye irritation, and the health impacts of this off-gassing until it starts to dissipate is known as sick building syndrome. So oftentimes we can see people in maybe new office buildings complaining of maybe skin or lung irritation, fatigue, nausea, or even severe headaches due to that off-gassing of those products. So don't forget that MAPs are very common on the AP exam. So if we take a look at this one, it shows some premature deaths from air pollution where they are more common and less common. If we look on the West Coast, notice that the deaths per 100,000 adults, it's on the low end. It's usually less than 1 or 1 to 5 individuals, whereas on the East Coast, where there is a lot of industrial production, we see much higher numbers of deaths in adults per 100,000 individuals. So if you look at the areas that are purple, there are a lot of industrial centers there. There is a lot of coal production there. For example, you can see West Virginia has quite a bit of purple over it. So those centers, we're going to see people having much higher rates of death due to different types of air pollution than we would maybe in areas that are not quite as industrialized. Okay, the last thing we need to discuss for Unit 7 is noise pollution. So noise pollution is when there are very high sound levels in an area, and this can be in a city, it can be in a suburban area, or it can just be out in the ocean, for example, from ships. Noise pollution at a high enough level can actually cause physiological stress, strain on the heart. It can cause hearing loss. And this usually comes from things like transportation. So you might have above ground trains, from vehicles, from the honking of horns on cars. It can come from construction. Noise pollution could even be considered high levels of sound from radios and headphones as well. Humans are not the only organisms that respond negatively to noise pollution. Animals can as well. It can actually mask their communication with each other during mating season or hunting, such as the dolphin you can see on the right that is trying to use echolocation. With a lot of noise surrounding that dolphin, they may not be able to hear the reflected sound waves coming back, which can make hunting difficult. Noise pollution has been shown to cause stress in humans and animals. It can cause damaged hearing just to the high level, the decibel level of noise, and also changes to their migratory routes. So when you guys watch your YouTube video I posted on noise pollution, it'll go into a little bit more of the research done with that. So that is the last of the Unit 7 air pollution notes.